Hello and welcome to another tutorial and the next part in the series on building a character controller. So last time we got to the point where we had jumping and falling and double jumping feeling really good, and we had toggles for all of those so we could easily balance that. We had support for in-air control, which in particular with the jumping helped get a really good feel there for it. And we set up a little bit of stuff there for some sound hooks for in particular landing on the ground. So this time around, our focus is going to be on tackling steps and some other general movement improvements there so the movement's able to be as good as we can get it. So if we dive in and take a look where we're at the moment, if we try, and so if I'll run this and then I'm going to attempt to try and climb some stairs, and we'll see sort of what happens at the moment. So there's a couple of things we want to highlight. So at the moment, if I go over to the stairs here and try and climb these, then I can't actually get up those stairs. The other thing we'll also run into is, so jumping is working, feeling pretty good. You know, I can double jump. If I get to an area where I've got something above me and then double jump, the movement is a little bit weird. And you kind of end up being stuck there. There you can see it sort of quite particularly. We get stuck on the ceiling for a bit. So we want to actually fix stuff like that as well. And the other thing, because something that's not uncommon for players to be needing and wanting to be doing, is, so at the moment I am actually applying an input, but it's not properly sliding along the wall there. So we want to also be adjusting that so we can have the character be nicely sort of sliding along the wall. So let's start with getting a few of these key bits sorted out. So we've got that movement cleaned up and a bit more robust and a bit more polished. That's really what the goal is. So first thing we want to do is, because it's a fairly straightforward thing to fix, we want to sort out the ceiling issue. So hitting into something above us and that causing issues. So I'm going to have a header for the ceiling check. Now this one I could just use the ground mask, but just in case I'm going to have a ceiling check layer mask. So we'll just be able to default to checking against everything, but we'll also then be able to adjust that. We'll have a similar thing where we have a range that we check for this. So we'll have a float ceiling check range. So this is going to be from the feet of the character up. So that's going to be, typically we actually might call that a buffer, because it'll be the height plus that buffer amount. So we can make that 0.1. And we might want a little bit of a buffer on the radius. I probably won't need that, but just in case we could also do that as well. So what I want to do then is, in character motor, we want to go down to where we are handling our jumping. So we've got our jumping logic, so we know at the moment we're jumping and we're doing updating for it. So at this point here, before we go and set the velocity, this is where I want to go and do that actual raycast. So similar to what we would normally do, I am going to do this. So this won't be a sphere cast. Could be a sphere cast actually. So we could do, sphere cast is probably a better one to do. I've previously just used a raycast, but I think a sphere cast will mean if we catch edges of stuff, that'll work a little bit better. So I'm actually going to largely steal from the ground check one, because it is going to be quite similar in terms of the behavior here for this. So with that, just need to reformat these. So we're going to have a raycast hit, ceiling hit result. So that can be stored in here. So vector 3 up. We're using ceiling check radius and ceiling check distance. Start pos can actually still be that offset amount there, I think is still fine. The radius, we will keep that. We could have a ceiling check radius buffer. Likely these will be the exact same as the grounded one, but it doesn't really hurt to have them be able to be a little bit different. So we've got those settings in, and then the ceiling check distance is, again, we take our height, we subtract the character radius and add in that little bit of a buffer. So we'll run that sphere cast. That's going to sphere cast up. If it has hit something, then what we want to do is say is jumping is equal to false. And we can set movement vector dot y to 0. So we just stop the velocity. That'll mean there'll be a frame where it has a bit of a stop, but then it will recover back afterwards. So that looks pretty good. We turn off jumping. Otherwise we'll go and just update the velocity as normal. So we can check our config for this, see if we need to do any updates. One of the things we do want to change here is that can just be checking against default. Water generally wouldn't make sense for a ceiling check. And we can make that so it matches. So that looks pretty good. So I want to test that, make sure now when I hit the ceiling, it doesn't have that period there where it sort of can cling to the ceiling, which looks quite odd. So with these, I hit it and then I fall back down immediately, which is good. Now, it is possible for me to get a little bit sort of stuck there. So at the moment, what it looks like is we are stuck in a little bit of a weird state. So we can't really jump. So this is something where likely that change has introduced some issues, but that's okay. So we can check and see, well, is jumping is false. Now, what we might be running into is if something else is using jump time remaining, it may not then be trying to make us fall at this point. So we're not grounded. That means the movement vector should have a velocity down, which we can see our velocity there looks like that. So it looks like it should be giving us a velocity down. And we can just check and see if anything else is sort of happening. What potentially is happening is something is going wrong. I think our grounded check, because we have a jump time remaining, which is then never updating. So easy problem for us to have caused. All that means that we need to do is when we have this, we also need to set jump time remaining to 0. So we just need to make sure that we're properly clearing that. So what was happening was because we weren't resetting that jump time remaining, that was able to be lingering for a chunk there. So what that should mean is here, can jump as normal, head over under here, we jump, falls back down, and we don't have that stuck behavior anymore. So that's good. So we've sorted out the jumping there. So then the next thing we want to sort out is being able to work with steps. So generally, if we take a look at the steps here, how we often want to handle this is when the character is, and I'll just create a capsule here that we can see. We'll just make it a little bit easier to visualize this. What we generally want to do is we bring this over this way. So when the character is here, so at the moment, they can't move into the next area. So what we do is we actually do a series of raycasts. So firstly, we do a raycast ahead, and we do that ahead to check to see if there is something that is blocking us. So we're looking for picking up that step is there. Then we offset our height by our step height. Then we do another raycast and check if it's clear, because that's going to tell us if the surface is actually then one that we can hop up onto. So, okay, we've done one check to know that we have a blocker there. If we do another check to say, can we actually stand, is it clear on top of that? And then the final check we do is we work out the new location that we would sort of be placing the character, and then we check and see, is that location clear? And also, does it meet the slope requirements? There's a few different casts that we do. We do 2 ones horizontally, then we do 1 vertically. So we do a raycast into this, a raycast over the top of it, and then a raycast down into it so we can check stuff like slope. So where we end up setting this up is here. So we are grounded. We are grounded, and we have already gone and projected our movement vector along the plane. So we've taken that, we've projected along the plane. We are grounded, we've done all of our slope checks, everything like of that. And then it's a case of if we are not jumping, then we want to actually kick off that step check. So if not is jumping, which we do that there actually, so I'm going to change this to down here. So if is grounded and we are not jumping, then check for step up. We'll provide the movement vector. So we'll have a similar thing here of protected void, check for step up. Vector 3, and that's a ref one, just in case we do want to update it. All right, so we need a few distances because we need to check a couple of different things. So we're going to have a header here, step up check. So I'll have a public float, step check, look ahead range. That usually is probably going to be a little bit beyond the radius of the character. So this is going to be how much sort of beyond the radius of the character we go. So we might say 0.1, so about 10 centimeters ahead of the character. Then step check, and then the max step height. So this is going to be how high a step can we actually take in one go. And this is going to be down to what's going to, the size scale of the character, things like of that. It's going to be down to sort of what feels the most reasonable there with that. So we might say 0.3. I'm trying to remember how large these are. They don't have a mesh render, or they do have that on them. Don't actually recall what the size of those was. I think they were something like 0.25. So we're going to go for 0.3 is our max step height. So, okay, first we do our raycast ahead. So that means, and we're not actually relying on any of the data from this, so we don't actually need our raycast hit, we're just checking has it hit something. So we do a physics raycast. We are checking from our actual, generally we want to do usually a little bit above our feet. Not a huge amount. We just usually want a little bit above our feet. So I'm going to set up a vector 3 here, and we'll call this look ahead start point. So we'll call that transform.position plus vector 3.up multiplied by our config, and we'll say we'll use the max step height by 0.5. And just check ahead that distance. So we raycast. From there, we're going to our direction wise. Well, that's going to be our movement vector normalized, which I'll cache that as well. Look ahead vector or direction is movement vector dot normalized. Just don't want to risk it calculating it multiple times when we don't need it to. So we do that look ahead direction. We give it our distance. So float look ahead distance. It's going to be config radius plus config look ahead range. So we have look ahead distance. Then in terms of what we use for the layer mask, we want just our grounded layer mask, so the things we would normally walk on. And we will, as we generally do with a lot of these, we will tell it to ignore triggers. So query trigger in action, we have it ignore triggers. So check if there is a potential step ahead. Then we are checking if there is clear space above the step. So in this case, the check we run again is almost identical. We actually, to the extent where we can do this, but what changes is that look ahead start point we add, because we're only checking half of the distance before, so we now will check the full distance. I'll actually just do equals, just in case we change the 0.5 here to something else at a later point. Just means this is always going to, we can rely on this being accurate. So we're checking now if there's clear space above it. So once we hit this point, we now know that we have a blocker. We have a clear space that is the step ahead distance above that, which means we can now check that surface. So this is where we then want to do an actual sort of cast down. So what we would generate is our candidate point, which our candidate point is going to be our start point, plus we take our look ahead direction times by look ahead distance. So we're just looking a bit further ahead, and then we're going to cast down. So this time we actually do want the raycast hit. And we'll check the surface of the step. So we'll have a raycast hit result. So F, physics, raycast, and so we are raycasting from candidate point. We are raycasting down. We have our hit result. The distance we actually cast down, we want enough of a distance that we definitely will hit the surface. So what I would generally do for this is something like step check the max step height by 2. So max step height would probably be enough. This just gives it a little bit more of a buffer. So max step height we could say almost certainly would be enough. We just want to give it that little bit more of a buffer though, just to be sure. So we're checking down, and we need to give it our usual grounded layer mask, and then again, ignoring triggers. So now we know that we have hit a location. We know that it's clear from the top. We need to check the angle of this, because this could be something that is too steep. So what I want to check is, okay, well, F, same way we check the slope limits otherwise, vector3.angle. What we can then do is from vector3.up to hit result.normal. And if that is less than or equal to config and our slope limit, then is the step shallow enough in slope. That means we now can actually confidently say we can step up onto it. So what we can do is we want to then change our linked rigid body dot position. We're going to modify that to we get the hit result dot point. So we're just going to directly move this. Now we could potentially do things like a bit of a lerp, stuff like that, but generally just setting the direct location there will be sufficient. So this should mean we can step up. Now we're still moving over a surface that is very jagged. So it doesn't mean that the movement is going to be smooth. The focus isn't about making sure that the movement is perfectly smooth. The focus is about making sure that the movement works. So we can see we get there a little bit, and it sort of is starting to try and do this. So what we want to do is be able to sort of test this. And this is something where it can be handy to have the ability to force a movement input into something. So having essentially a debug option for overriding the movement. So debug controls, we'll move this down here. And what I'll have is serialize field will override movement is false. We'll make that debug underscore like that. So that will be good. We'll make that protected, and then we'll also have a protected vector2 debug movement input, so that I can check, and if this is set, then I use that debug value. So where that comes in, how I would actually use that is down in our setup where we're actually working with our input movement. What I would do is, okay, well, F debug override movement, then input move is equal to movement input. This is going to make debugging things like of steps much easier, because it can be very hard if you're switching between trying to provide particular keyboard input, stuff like of that, to have that working for testing this stuff. So what I'm going to then be able to do with this is I should be able to select the player, and then with that player I can turn on the debug movement here, and the movement is just going to be forwards. So I could make this 0.5. And so now I've got input constantly coming into it, which means I can then very easily be doing the step checking. So it makes it a lot easier for testing that. So now I can see, okay, it's getting our start points. So it's doing the first raycast. So we can see does this first raycast pass? And so that hasn't actually hit anything. So we want to have a look and see that look ahead distance was 0.4 and the start point was at 0.15. So that tells us and this time it did actually hit, so it can vary a little bit. So it's hit something. Then we can check if there's clear space. So it didn't find clear space above it. So what it could be is the height of those might be more than the actual sort of step up distance. So if we look at this, the start point that it's using is 0.3. So what I can do as an easy way to sort of see what might be happening is I can go to the scene view, and if I pause it, just so it's not changing, I can just create, easiest way to check at a particular height, let's create a plane and set the height of that plane to our 0.3 value and bring this over. So 0.3 is just above it. So that looks like that should generally be clear. So if it's using 0.3, that should actually be clear. Now, if I set the breakpoint here, we just want to check each of the bits in terms of the distance, because the radius of the character, we might also have that not quite correct. And let's take a look at our character. So we can see the character's radius here is 0.35, whereas we in our configuration, we have 0.3. So let's fix that up to 0.35, just so we're being consistent. And then we're going to test again. So we'll do a similar thing where we'll head over here. We will line ourselves up with this. That's just going to then make it a little bit easier. So line ourselves up with it. We will override our input. So input can go to being 0.5, turn that on, and then that time we were able to successfully step. You can clear those breakpoints, and we can go back to testing this, except need to turn off the override movement input, otherwise it's going to be very not pleasant. So I can successfully step, and this is also a really good illustration of, yes, we can step up things, but we are understandably going to get a little bit jittery movement because that's what we would expect. You can also notice we can move off of stuff, but we were running into issues with stepping down. So we saw we were running into some issues when we were sort of moving this particular downstairs where it was failing to move. And the reason why that happens, it's going to be easiest if I actually add a capsule to this sphere. It's just for placing it, and then I can reset that back. So this capsule is the player. And because we're doing a sphere cast, so doing a sphere cast over a range, it's kind of going to give us a capsule shape. So when we're there, it's fine. Capsule cast goes down, it hits the ground here. But as the character moves along, and I'll position myself here, so as they move down, at a point like of this, the intersection that happens is going to be here. It's going to be at this contact point. And what that can mean is that the normal we get from that result is off, and it thinks that it's actually on a very sloped surface, which then means the movement vector it generates can be quite far off. And so it ends up generating, it thinks it's on quite a steep slope. So rather than generating a movement vector that goes ahead, it ends up generating a movement vector that is pushing this into the ground. And so that means that it can then very easily get stuck because it's not going to tend to move. So that's the issue that we're running into with this. So there's a few different ways that we could be going about sort of solving that. One of the things that we could do, because the main reason we're doing that sort of raycast and projecting the movement is so that we can make sure we're moving nicely along slopes. So what we could do is the grounded check could use the sphere cast, but then the actual projection check here could just use a regular raycast, or the grounded check could change to a raycast as well. So there's a couple of things we might want to change there for that, just to sort of resolve it. So I've time jumped forward a little bit and I've added in a quick update here. So with the positioning of things where it was having some issues at times going down steps, I had thought that that was fixed because it was seeming to work more reliably, but I did then with running further using of it was still running into some issues intermittently. So I've actually gone and made a change, which isn't in the version of the code that's tagged, but it is in the very latest version of the code. And you can see here I have switched from a sphere cast to a raycast for the grounded check. So that has helped out quite a bit. So that's one big change that I made. A couple of tiny changes that I did make. So with I was updating the physics materials, but I wasn't updating drag. So you can see what I'm doing is the rigid body itself has drag. So I'm keeping track of the original drag. And then when we are finishing jumping, so if it wasn't grounded and now is, then I restore the drag back. And what I do when jump is triggered, the drag gets set to 0. What that means is that just changes things a little bit, so that what we'll find with this change is we can really press hard up against something and it doesn't impact our ability to jump against it. So it makes a big difference with that. The other thing that I have changed, and as a result with the change for the slopes, moving up and down stairs is a lot easier. It's very hard for those to get stuck, and slopes work a little better also. The other very small change that you'll notice, and this was added mostly as a quality of life thing in the editor. If I go to the update camera function, I've added in this. There's a very brief, a little initial lockout time where camera input gets rejected entirely. And this is just after launch. That allows it to, because I tend to always be playing by hitting the play button, and then it can pick up, there's a few little frames where it can pick up a really rapid camera movement of the mouse, and then that results in the character looking at the floor. So just having that little initial discard time, it's not enough that the user is going to notice, it's enough that it actually improves that sort of quality of life there in the editor. So those are the main changes. So through the power of editing, I'm now going to travel back in time to the rest of the tutorial. There are a couple of other changes we want to make to sort out that sliding, which those changes can have a bit of an impact on this as well. Because when we're jumping, things like that, we want to actually allow the character to slide around a bit. At the moment, if we jumped against a wall, the movement is going to not be good. So I'll pick a wall here, and if I jump, it's very sort of clunky movement, and we actually, when we're hard against the wall, if I'm pushing against it, I actually can't jump. And we already saw the sliding and things like of that being a little bit odd. So what I want to actually generally do for the character is be able to change the physics materials. So if I set up, we want to have two physics materials. So physmat default, and then we'll also have another one, which will be physmat jumping. This will allow us to swap between these particular materials, which is going to make it work a little bit nicer, which will be good. That will actually work quite effectively. So the combine method for the jumping, we'll change that to minimum so that the friction is always going towards a lower level. We're going to, in our config here, set up header physics materials, and we'll have a public physics material default, and a public physics material jumping. These just give us a little bit better movement results. So then in our start, we want to actually switch these over. So for that, we need to be able to talk to our collider. So that all gets set on the actual capsule collider. So what we're going to have to be able to do is be able to retrieve our collider. So we'll have here the rigid body we already retrieved like of that. So we'll have a protected collider, linked collider. It doesn't need to be the very specific type of one. That's going to be fine. So get component of collider. Then in start, we'll do linked collider material is going to be equal to, so we can set that to our config material default. Then our jumping, we want to, when we start jumping, so any of the spots where we set jumping to true, we're going to change our physics material. So config, linked collider material, a config, and a jump one. So that's good. And then all we'll do, we don't want to reset it as soon as jumping is turned off because we could still be in the air at that point. What we will do is when we return back to being grounded, because we're already picking up on the fact that we return back to the ground, so it's quite easy for us then to do a setup here where we actually update that. So we've already got our update is grounded. We can store here was grounded. So that's where it's changed from running. Then we would check, well, if was grounded, it's not equal to is grounded, and it now is grounded. Then we return the material. So switch back to grounded material. That should just give us a little bit better movement with when we are jumping, if we're jumping against an object. It should just mean that that behaves a lot better. So we can link up our two materials, our default and our jumping one. So now that we've got those materials set up, we can test this. And what I'm going to do is, as I'm running into it, you can see it's still not updating. It's not letting us jump. So that's because we actually needed to make sure when we are going and doing jumping, we're going to change our frictions to 0 because we want to be able to just be sliding along stuff. So I'm going to move here, be backing into this, so we can see we can still jump. It does still slide along it. So that's better. Now we do want to then check and see how the movement behaves with these stairs and moving up and down them now, because we have made some major changes there with, assigning physics materials is going to change the behavior here. And we can see that has sorted out the movement with the stairs. So that's nice and smooth, which is good. So we've got smooth movement along the stairs, got smooth movement here. The one thing we've still got though is this, where it's trying to actually push into the object there, which we really don't want that. Doesn't look good. So we did notice we were having issues where, especially after the step-up changes, that we were able to be moving inside this. And if we switch this to down here, so we can actually be looking and see the character actually moves quite a distance inside. And that generally shouldn't happen. So, the physics side of things, the rigid body, I've switched it over to continuous, so it should be more reliable. So that means it's something other that's bypassing a lot of those physics checks. So this is something where step up is a thing we added. So we can check and see step up logic should not be triggering at this point, but it is. And so that's going to move that character forward. And the reason that's happening is very, very easy thing to have happen. So the first thing was checking, and it is supposed to look for an obstacle. This last one is looking for an obstacle. This one is looking for a clear space. So our second check actually needs to use a not, because we want there to not be something there. Now, if we run this, and I'll bring us back so game view is in full view, what we'll be able to see, so we can run over to this, and we don't end up going through it. We also are jumping, it's working reliably. We can move up and down slopes, except if they're too high, then we can't. So it's checking that slope limit. We can happily move up and down stairs, fall off the side of them. So we've got our full set of movement going. We can jump, we can double jump, we've got independent controls for those. We can be falling, we can be jumping and sliding along objects when we are near them. We have that basic step-up logic working as well. So we've got all of those key essential bits for our character movement up and running. So next time around, we're going to take a look at a few more sort of just polished features. So getting stuff going in terms of all of our sound effects, areas like that able to be hooked up, and a few other quality of life improvements there as well. Just little bits to improve sort of the capabilities of the controller. But for now, we've got our character controller up and running to a level where it is time for the character controller to become a prefab, because that is working well enough that it is absolutely prefab worthy. And we'll even put all of this stuff into its own folder now that everything is working, and to a level where we could be using this fully in a game now. Sound effects will get hooked up next time. They're quite straightforward, and those will be the key remaining bits. Thanks, folks. I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. Really helps out, really appreciated. If you're looking for the code for the project, that code is available up on GitHub, and the link for that you'll find in the description below. As with any of the projects, you can use this code in any of your own, whether those are commercial or non-commercial ones. And if you've got questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link for that in the description below as well. But until next time, bye.